Morning, everyone. Let's do assessment preparation 4C today. First thing we're going to do here is find the saving plan balance when it has an APR of 4%, monthly payments of $255. To do that, we are going to need a formula here that says, it's called the savings plan formula. The A, which is going to be our balance, is going to be the monthly payment times, and then the numerator is going to be 1 plus the APR over the number of payments per year raised to the n y, where y is the number of years, minus 1, and that gets divided by the APR over n. Now, all this is really the numerator and all that's the denominator, so there we go. So we're going to use that formula here. I'm just going to go ahead and use my calculator. I'm not going to try and do this by hand. Let's go ahead and pull my calculator up here and stick that over here as well. And let's see if I can get, should be able to get, okay. Let's put that down there, put this on the left there. All right, so there's my formula and my numbers here. So we're going to have monthly payments of $255 times, and then we have, this is a double set of parentheses here, a parenthesis for the numerator, a parenthesis to open up the expression, 1 plus my APR, which I'm going to write as 4%, divided by n. This is monthly payments, so this is going to be 12. We assume monthly payments unless told otherwise, raised to the, and then up here, we might need parentheses if we don't have a calculator like this. It uses math parent. I do have math parentheses, 12 times, and then the number of years. So that's 9 over 12, right? Because 9 months is 3/4 of a year. I'm going to call that 0.75. Then come down here, we say minus 1, close parentheses for my numerator, divided by, I'm going to open some parentheses for my denominator, APR divided by 12, again, for the number of months. And we get an amount here of, and it says to, it doesn't say, so I'm going to round to the nearest cent, 2325.84, right? $2,325.84. I'm just going to go ahead and go through and show you that now I'm going to show you something else here. So apps, finance, TMV solver. So N is going to be the total number of payments. That's going to be this NY up here. So that was my, I'm going to have 9 payments. My interest rate was 4%. My present value right now, when I start off, is nothing. I'm making monthly payments of $255 into the account. I want to find the future value. payments per year is 12. Interest is calculated in 12 cycles per year. I'm going to come over the future value. I'm going to hit alpha solve. Remember, I think we talked about this last time, that this comes up negative because the bank is paying it back out to you, and there's your answer. So yes, know this formula, be able to write it down, but I'm just going to go ahead and use the calculator here since everybody should have this app. I'm just going to quickly go through and solve these problems here with this formula. So 17 months means that we should be making 17 payments here. Interest is at 2%. Present value 0. Payment is going to be $551. And I think that's all that I need. Alpha solve. And we have $9,492.94. Let's keep going here. We're going to have 32 months of payments. We're going to need to watch out on the last one because we're going to turn the time frame into years instead of months. Okay, so watch out with this one where it's years and monthly payments. We'll have to watch out on that one, but all these other ones are months and monthly payments. So we're good to just take the months and put it in as F. We've got 2% again. Our payment this time is $393. And we again have 12 cycles per year. Alpha solve. We're going to get $12,906.36. This last one, watch out, we've got 8 years. So to get the number of payments, I need to take those 8 years times those 12 months to get the total number of payments that I've made. It's 96. We've got a 4% APR, and our payments are $473. And we're going to find the future value again, alpha solve. This is going to be $53,410.47. So again, you can use your formula for all of those things. Let's move on to the next set of problems. Though Stephen sets up an IRA with an APR of 4% compounded monthly. When he's at age 26, at the end of each month, he deposits $37 into the account. How much will the IRA contain when he reaches 65? Compare that amount to the total amount of deposits made over the same time period. Okay, so again, we can use this calculator here for most of this problem. We're going to say that he has a time frame from 65 minus 26 is 39 years, right? So he's going to have 39 times 12, 468 payments that he's going to make, 4%. And he deposits $37 into the account each month, and calculated 12 times a year. And let's solve that. We should have 41,586. and 6 cents. Now the question was, compare that to the total amount of deposits that he made. So he made 468 deposits of $37. So let's take a quick look at that. 468 times 37 is $17,316 for a difference of this difference that I'm finding is how much interest he earned. By the way, this is how much principal he put in. So there's a difference of him earning $24,270.06 in interest that he did not put into the account himself. Okay, so let's go ahead and let's do that again on the next one. Put in $192 per month. It pays 5% compounded monthly, right? So monthly. How much money will you have after 19 years? So this is 19 times 12. We're going to solve that. We should have 72,834.57. And we're going to compare that with n times principal. So 228, times the payment value times 192. It's going to be 43,776, 72,834.57. So 72,834.57 minus 43,776. It's going to be a difference of made $29,058.57. Okay. Do it all again, right? And here, college fund for your baby that has an APR of 5%. Monthly compounding, you want the fund to have a final value of, it's going to be final value of 359,052. That's what you want to take out at the end. Sorry, no problem. 173,282. That's what you want to take out at the end, right there. After 18 years, 18 times 12. And how much should you deposit monthly? Your present value is going to be 0. So you want to solve for the monthly payment here. And we get that you should be paying $496, and don't round down here. I mean, yes, round down to get your answer that's on the answer key here. But if you want to have at least this much in your kids' college tuition fund when you're done, don't round down because you'll have less money than that. You should actually round up. So the answer key is going to say 22 because of regular rounding rules here, but you need to know in real life, you would actually need to put in 496.23 at least. You'd need to put in at least that much if you're trying to get at least this much out. So think about it, see if that makes sense to you. If not, ask me. I'm going to go with the answers that are going to be on the answer key, but understand that if you put less than this exact number, which is more than 22 cents, if you put in less than that, you're actually going to get less than this out. Okay. That goes back to some of that logic stuff that we talked about before. Let's go ahead and let's talk about this next one. Suppose you are 25 years old and would like to retire at age 65. Furthermore, you would like to have a retirement fund from which you can draw income of $359,000 and $359,052 per year forever. How can you do it? Assume an APR of 5%, which we have there, compounded monthly. Okay, so what that means is that I need that right there, that $359,052 to be just the interest. I can take out the interest and not touch the principal. If that's my interest payment every year, then I should be able to do that. So the first thing I need to do is find out how much interest is going to be calculated monthly. So that means that my interest every month is going to need to be $359,052 divided by 12. I want this was per year. That is going to equal $229,921 per month. Okay. So far, so good. So now I need to figure out if that's what I want to take out every month. Then, and that's the interest. I equals P RT, right? Let's see. No. I need to say 5% of what is that. So 5% of, erase. So this is in my way. 5% of what amount P is equal to this is going to be over 12. It's equal to 29,921. Okay, that. So take this big number, had 359,052 divided by 0.05. We should get that we need a total amount of our investment at that point to be 181040, like that. We need over $7 million in the account. Now I can come back to my PMV solver. Okay, so I should be able to come in, or TMV, TVM, whatever. So I should be able to come in here and say, I want my final value to be $7,181,040 when I'm at age 65. So this has been 40 years. So 40 times 12, 5%. It's starting off with nothing, and 12 cycles a year. And we need to deposit how much money a month. Alpha solve, we're going to have to put in $4,705.73. You actually need to put in a little more because it's more than 73 cents, but we're going with regular rounding rules here. Each month, that's how much you'd have to put in to be able to live off of the interest once you hit age 65, if you believed that you would need $359,052 per year in interest payments so that you didn't touch your principal. That's somebody with a lot of money, by the way, but all right, that's how you could do that. There's an example like that in your textbook. Moving on to number 9. 5 years after buying 200 shares of stock XYZ for $45 a share, you sell the stock for $20,000. And you want to find the total and annual returns. Okay, so total returns. Let me clear this stuff up here. Now that we're on to a new topic, our total returns are calculated by my total amount at the end. You could call this future value in the calculator and this present value in the calculator. So I'm just going to write that as calculator terms. This is going to be final value minus present value over present value. Okay, just so you know with the calculator what that is. Those are some other variables that Excel uses. And for our annual return, we're going to get A over P to the 1 over Y minus 1. And again, that would be final value over present value to the 1 over Y minus 1, like that. So I'm going to get off the screen. This solver isn't going to help me as much with these problems. And we're just going to use the calculator here. So 5 years after buying 200 shares at $45 a piece. So the initial value was 9,000, right? Initial value was 45 times 200. Yeah, 9,000 is my present value. The future value, they told me, is $20,000. That means that A minus B is going to be $11,000. Be consistent with this and call this P. Call that A. And then my A minus P is, all right, got sloppy and you can't see that that's an 11. There we go. So we've got our total yields are going to be 11,000 over 9,000. The thousands are going to cancel each other out. 11 over 9 is going to be 1. Let me show you. 11 over 9. It can be 1.2 repeating. So this is going to be 122%. Going to the nearest hundredth of a percent, it's going to be 122.22%. Now, our other part here, annual yield, is going to be this A, which was the entire 20,000, divided by the 9,000. I'm getting rid of the thousands because they'll cancel each other out, to the 1 over 5. This was 5 years minus 1. And this is going to be 17.32%. All right. Next problem. 4 years after buying 400 shares at $50 a share. So that's my initial investment of $20,000. We sell the stock for just $2,000, so we have lost $18,000 on this investment. So we're going to divide that 18,000. It's negative, divided by my initial investment of 20,000, right? And that's going to be a negative 90%. Then I'm going to take my A, which was my 2,000, divided by my P, which was my 20,000, raised to the 1 over Y, which was 4 years, minus 1, and I get a negative 43.77%. Let's keep going here. So initial investment, final investment, so 88.77 minus 14,077 divided by 14,077 is a negative 36.94%. And then we're going to take the final divided by the initial, this needs to be in parentheses so that I can raise that to the 1 over number of years. It's 5. I need to subtract 1 there, and this is going to be a negative 9.22%. We're always giving these answers of our yields as percentages, or our returns. Sorry, not yields, returns. 7 years after paying that much, you sell the shares for that much. So again, we're going to come back. Final minus initial divided by initial. This should seem like a familiar formula to you because it's percent change, right? This is a 232.33%. 34, excuse me. Rounding. This is 3.4. And then we're going to take the final divided by the initial, raised to the 1 over the number of years, minus 1, makes that 18.72%. All right, page 1. Almost done here. Calculate the current yield for the treasury bond with a coupon rate of 4%. It has a market value of 85%. So let's come up here and show you the formula is the yield for you is going to be amount you earn divided by the amount you pay, right? So so for 13 and 14, just going to work them out on this whiteboard up here. The amount you earn is going to be 4% of the face value of the $100. So the amount you earn is going to be $4. The amount you paid right here, you paid the market value of $85, even though it has a face value of $100. You only paid $85 because you got it. You always pay a little less upfront for these things, or you should. That's how they're supposed to work. That's what the idea of the coupon rate is. So that would be 4 point 0.71%. Have this written down. Fixed. Okay. So, okay. Let's do that again with number 14. And that's going to be 7.1% of 1,000. So you're going to earn $71. You're going to pay $750 for that. So 71 divided by 750 should give you a yield of 9.47%. Let's move on to 15 and 16. You need a different formula there. So our current yield is going to be the, let's just say equals the annual interest divided by the current price. It's actually not that different from what I just showed you, that other formula. So if I want to find the annual interest, that means that the current yield times the current price is equal to the annual interest. Okay, this is for number 15. So they tell us to calculate the annual interest for a $1,000 treasury bond with a current yield of 2.5%. That is quoted at 109 points. So 109 points means that it's 109% of its face value is its current price. So that means that its current value is $1,090. So if we just take 109% of the $1,000 face value, that's how I got the current value of $1,090. I'm going to take that times my 0.025, and that tells me that my annual interest is $27.25. I'm going to do that again. I'm just going to switch colors here. I'm not going to write all the formulas out. That go ahead and write the answer in here. This is 27.25. Come back up here. This is going to be a 3.5% current yield and it's 115.8 points for a $1,000 treasury bond. So that means that its current face value is 1,158 dollars. Again, if you just wanted to see that here, that's going to be 115.8% of the $1,000. That's how I got that. It's going to be times the 3.5% current yield. Shows me this is going to be 40.53. Oops. To write the correct answers in the correct blanks here. So this is 4.7%, 9.47%. This was 27.25, and problem 16, which I had hidden, sorry, was what I just worked out was $40.53. That is the end for this video for 4C. We got one more video for Unit 4, I think. So we'll come back and do 4D next time. All right, have a good day.